Hello students, so let's try to solve one problem from CSIR NET examination, and that is question number 36 as a question is given onto the CSIR NET website, and its question ID is actually 252. It's a wonderful question, mainly on postulates and as well as operators. And let's discuss this question. So there is one Hamiltonian, and this Hamiltonian is written in an abstract basis of ket A and B. So it is given E0, A ket, and A ket, and there is E0 plus delta, B ket, and B ket. And A and B are orthonormal. So that means we have A and A ket is equal to 1. A and B ket is equal to 0, and obviously B and B ket is equal to 1. And there is a one operator, that is parity operator, is defined, and when parity will operate on A, it is given when parity is going to operate on A, it will shift to state B, and when parity will operate on B, it will shift to state A. So these information are given, and more information, and these all are facts given about this particular system. We don't know which type of system is there, but mathematically we can do all these things. And it is given at t is equal to 0, there is a two-state system at psi t is equal to 0. When we are applying this parity, that value is psi t is equal to 0. So that means when P will apply on psi t is equal to 0, we will get the same psi. That means we have even parity. And what we have to do, we have to find after what time t, this psi will be going to have minus psi t. Means after what time t this situation is going to happen, and you have 100% probability that you will get minus, say, parity or odd parity of a system. So obviously we can see that there is time evolution, and unless until we will not get the eigenstate and the eigenvalue of Hamiltonian, we cannot do anything about the time evolution. So let's try to figure it out. What is the eigenvalue and eigenstate of Hamiltonian? So obviously we can try it, and hence A and B are orthonormal. Then we can easily check. We can easily check that HA is equal to E0 A, and we can check HB is equal to E0 plus delta B. So these are the story you can easily check. You can apply A here, you can A here. So A and A, you can have 1, B and A will be 0. So obviously you can have this information. So yes, it's a very good thing that this A ket and this B ket are the eigenstate of Hamiltonian with eigenvalue E0 and E0 plus delta. So it's a very wonderful information. Now we can create a state at t is equal to 0. So let's try to figure out this particular state. So let's say that psi at t is equal to 0 is given by some C1 A ket plus C2 B ket. And this C1 and C2 are unknown to us, but there is one information is given that when we are operating pi on psi t is equal to 0, we will get exactly same function. That means we have even parity. So when we have parity p at t is equal to 0, we will get exactly same function at t is equal to 0. That means C1 parity of A plus C2 parity of B is equal to C1 A plus C2 B ket. And if we are applying parity on A, it will flip to the B. So this is C1 B ket plus C2 A ket, and here is C1 A ket plus C2 𝐉𝐶at. Now, if we are going to compare these two things, we can have a relationship between C1 and C2, and then we can say C1 is equal to C2. And obviously, if we will use the normalization condition, then mod C1 square plus mod C2 square is equal to 1. Then C1 is equal to C2. I can adjust it with 1 by root 2. So yes, we can find this particular state at time t is equal to 0. So we can use this space that psi t is equal to 0 is nothing but 1 by root 2 𝐴𝐶at plus 𝐵𝐶at. And we can write this particular thing. This is my psi at t is equal to 0. Now let's go for the time evolution, because we have to calculate after what time t the whole wave function will have 100% guarantee with have 100% probability that it will be into the odd parity. So let's try to go for time evolution. So obviously these all things are have not used for the next step of calculation. So we have this particular psi t is equal to 0. We can write psi t is equal to t, and this value is 1 by root 2 𝐴𝐶at e to the power minus I E naught t upon ℏ, because we have eigenvalue E naught associated to A, plus we have 𝐵𝐶at e to the power minus I E naught plus delta t upon ℏ. So this is our state after time t. This is general state. But what are constraint? The constraint is that P of psi t is equal to t. The situation that after this particular time, we have minus psi t is equal to t. So when we will apply this parity operator on this particular thing, then what we will get? So we can use this space also, because the whole thing will be a little bit lengthy. So what we have 1 by root 2 parity of 𝐴𝐶at e to the power minus I E naught t upon ℏ plus parity on 𝐵𝐶at. Sorry, this is parity P on 𝐵𝐶at e to the power minus I E naught plus delta t upon ℏ. This must be equal to minus psi t. So this minus sign is very important. So when parity will apply, again it will flip to B. So 1 by root 2, and this will be B e to the power minus I E naught t upon ℏ, plus parity will apply on B. We will get A e to the power minus I E naught plus delta t upon ℏ, and this value is minus of this particular thing. So this is minus 1 by root 2 𝐴𝐶at e to the power minus I E naught t upon ℏ, and we can go for 𝐵𝐶at e to the power minus I E naught plus delta t upon ℏ. So obviously 1 by root 2 has not any significance. So we have to find the minimum time t from here. So what we will do, we will just take this one outside, and this minus sign is there. We will take this one outside. So only coefficient is there, and only coefficient is there. And again, we will compare the coefficient of A and B, and we can get the final answer. So let's try to go for. So if we are taking this thing outside, then we will have 𝐵𝐶at plus 𝐴𝐶at, and we have this minus sign will cancel out, because when it will come to here, it will be plus 1. So that is minus I delta t upon ℏ must be equal to minus 𝐴𝐶at minus B e to the power minus I delta t upon ℏ. And this equation will hold only if we have e to the power minus I delta t upon ℏ is equal to minus 1. That implies delta t upon ℏ is equal to pi, and we can get t is equal to pi h cut upon delta. So according to your option, the option number B is the correct one. And this is a very wonderful question. Absolutely a high level of concept about the quantum mechanical system, about the parity operator, about the time evolution, and the representation of Hamiltonian in an abstract way. So if you want to just do revision of all these things, how your parity will works, how time evolution will works, and then this question is really a gem of this. Try to practice it, and if you have any suggestion, it will be always appreciated by us. Thank you.